at question number 35. In question number 35, the question says, we wanted to graph this. When you started graphing, what is the first thing I know about number 35 if I want to look at its vertex? What do I know the vertex is going to be located if I'm looking at it? Tanya, what do I know? The number out here tells us what for our vertex in 35? How far we move up. So we're going to go up 3, right? And then this minus 2, in order to get our x-coordinate of the vertex, good, you're here. If we are looking at our x-point of the vertex, what am I looking at for this part, Owen?
Positive 2.
Positive 2, because I need to look at those two giving me 0. Good, good, good. You didn't need that. Did you miss any others?
No, I haven't.
So, when we take a look at that, and then, does this look like yours? Yesterday? If not, just I can take it back.
I
So-
don't think so.
Yes?
I don't think so.
You decided?
I turned it in.
So, we are looking at our vertex, and it says if you graph this. So I should see on your paper that you did a graph, yx, and I should have seen over at 2, positive 3. Should this graph be going up or down? Opening up or opening down? Should be opening up as I was looking at that. And I should have had this as your graph with a slope of 1 and -1, right? So it says the vertex of the absolute value is at what point? And the graph is at the point which the graph changes direction. What is the vertex of this one? So our vertex should have been 2, 3. And it says, well, what is the relation between the vertex and the equation? We're going to add this into our notes today when we take notes. This is a pretty big part right here. It says, if we look at y equals absolute value of x minus h plus k, what do you notice about this vertex? Well, the k value, that was our 3, right? So k is always going to be, if it's a plus k, that is always going to be our y coordinate back here. So when we are looking at any time you have a plus k, that is going to be the y coordinate of our vertex. Anytime you have a minus, this will be our vertex, and this will be the y, if we are looking at that. This will be our x coordinate. Our x coordinate, if it is a minus, will just be h. Now, if it's a plus, right, then it has to be the opposite of that, because we always have to think of it as a minus. So kind of like your point-slope equations, remember in point-slope, you always had to make sure it was x minus and y minus to get the number for what that point was. This is the same thing. So we're going to be using this today, okay? So that was kind of number 35. Number 31 asked you to, what are the points on the graph where these two intersect? And it says, well, how are the graphs related? So what's their point in common? That's the first answer to 31. So 31 says, well, what do they have in common? They have one point in common. It is an XY point. It says, well, how are the graphs related? So let's look at that first. By just looking at the two equations, what is one of the things I know about both their slopes, Otto? Both slopes because of the number out in front here. They're both gonna, so if we're thinking of number 31, what do we know about both graphs, how they're related? They both have slopes of 1 and -1, right? That makes sense? What else do we know, Ryan, about the graphs? What about that V shape? What's gonna happen? Is it opening up or opening down?
It's opening up.
Okay, so in 31, if you don't have this done, you want to make sure you have this for 31 in your, that what I'm doing. Same with 35, you should have those two done. So the V shape is going to open up in both of those. How are they related? They both have the same slope. What is different about them is that they have different what? That we are looking at, Becca. What's going to be different about them?
They both have different starting points.
Both different starting points or different vertexes, right? And the question down here then says, well, could you use a graph to do this, or could you actually use, if we were looking at this, or could you use a table? Okay, so if we are thinking about question 31, and I'm just going to kind of do 31 down here to finish that because I have a little more room. So if we are looking at those two equations, we had y was equal to absolute value of x minus 2, and y was equal to absolute value of x plus 4. If I'm looking at my vertex, my y coordinate of my vertex did not change. This one should be 2, 0 for my vertex. This graph, if I'm looking at it, should have a vertex of, thinking of that being this minus part, should be a negative 4, 0. So if I am graphing, I have one over here at positive 2 and one over here at negative 4, right? They're both V-shaped, they both have slopes of 1. So I know like this graph is going to be going like this. Same with this one, right? I'm trying to find this point of intersection. Now, for some of you, it might have been easier on the graph. It looks like it's going to be where? My graph isn't drawn exactly right, like with your graph paper, but it looks like it's going to be when x is what value? Negative 1, okay? So you could have actually graphed this and plotted it, and then think about your xy table. Now, my first y is when x, absolute value of x minus 2. I'm going to do 2 y's back here. The second y is going to be for this equation, and I'm going to put y equals absolute value of x plus 4. And we think it looks like negative 1. It's definitely not 0, because these are going to be it's 0. This one's way up here, so those are very different. So when we look at this one, we think negative 1. So if I would have made a table of values, and if you were thinking of a table of values, that would be like 0, negative 1. Maybe it's negative 2. I don't think it's negative 2. I think it's negative 1. So I'm looking at that, and that means I'm going to this equation, which was the absolute value of negative 1 minus 2. Absolute value of negative 1 minus 2 is an absolute value of negative 3, and that does equal 3. So this point I know on one of the graphs was negative 1, 3. If I check it over here in this equation, so if I'm checking it in this equation, I'm going with absolute value of negative 1 plus 4. Absolute value of negative 1 plus 4 is 3. Absolute value of 3 is 3. So both of these came out to be the point negative 1, 3 and negative 1, 3, which means that is my point of intersection right there. Okay? So knowing this part and knowing how we find the vertex, you should be able to graph number 37. Should 37 be pointing, should the V be opening up or opening down? If I look at 37. If I'm looking at right out in front, Marie, what do you think? Down. That negative out in front is telling us down. This should help you to get your vertex, okay? We're not handing that in today, so if you didn't finish this through those last questions, you can do that for tomorrow, okay? Make sure you need to stop in and get some questions on it, okay? In your notes, we now want to go to C7, which are our characteristics. So, notice again the I can statements. Tomorrow we will be really doing this piecewise function. That's what number 21 was in your homework that I said to skip. That's where we'll do the piecewise functions tomorrow. Okay. So today we're going to have a worksheet that we're looking at. So we want to look at these. Is there a minimum or maximum point as we are looking at our graphs? And what do we know? So we will be using your device very shortly. Key thing is absolute value. Are those functions when you graph them? Does each input give us one output? Does it pass the vertical line test? Every absolute value is a function. So it says absolute value function. It could be written this way. How have we been writing ours? We've been writing it with y equals absolute value of x. Okay? You should notice that You might see this more often when you get into your upper level math classes because they're really looking at function notation. I know our Algebra 2 is pretty heavy on that at the high school of using this notation, and we will use this throughout the year, okay? So when we think of our characteristics that we talked about yesterday, what does the graph look like? That means your characteristics. Joey, tell me one thing.
This graph look like?
Yeah.
It's a V.
It's a V shape. And if it is our parent function, it should open up. Another thing we know, something else from yesterday that we talked about, that parent function. What's something else that we know? Becca.
Parent function. It's always like 1, 1.
So the slopes are always going to be 1 and negative 1. Something else is important about that parent function. There's one other thing that's really important where I know how to graph it. Anyone remember? Raise your hand. Got something else for me? Devin? The special point that we had to have in our graphs, Brooke, called the what? When you graphed yours yesterday, where did you always figure out how to start out? It was called the what? Not necessarily the origin. The what, Joey?
Vertex.
The vertex. We needed to know our vertex, and in the parent function, our vertex was the origin, always 0, 0, right? So vertex was 0, 0. It's V-shaped going up. Slopes are 1 and negative 1, right? Those are the key characteristics of this parent function, okay? So what it looks like, it's V, slopes 1 and negative 1, vertex at 0, 0, okay? Today we are going to, it says, investigate using technology. Other years we've used graphing calculators. We are not going to be using a graphing calculator today. We are going to be using your device. And on your device, on the daily planner, so if you take your device out and you get to the daily planner, on the daily planner, when you look at your plan, and so you can just look on, do you have yours with? Did you not hear me say we need devices? All right, go get yours quick. Yeah, you need it. It'd be good since one of you on it, you need it. So as we look at this, go quickly please. As you look at this for today, we are looking at, I need to go to this week. On this week, you will see Desmos calculator. That's what I want you to go to. I want you to go to Desmos calculator. So, yours should look like this. Get it to Desmos, click on the calculator. I had someone in the last class said, oh, so you mean if we were looking at our homework here, and they were looking at, oh, you mean this is like a video of it, and these are the notes, and this is the worksheet? Yes, they're all there, okay? We wanted to go click on the Desmos calculator, so we're looking at that calculator. Everyone should look like this. Okay? We want to type in the equation that they give you. They said y equals, and we were looking at the absolute value. The absolute value is going to be that key down here as you are looking at yours. So if we look at that, the absolute value, we are going to put in exactly what it says, x plus 1. So you can click on the x. Once you do that, that's our parent function, right? Plus 1 inside that absolute value. Then you're going to move outside the absolute value, and we are going to put minus 2. Does that make sense for where our vertex was supposed to move? Right? We said this has to be 0. So what would x be for the vertex? Negative 1. The y coordinate is negative 2. So as you are looking at this, okay, please plot this right now. Negative 1, negative 2, plot it on in your notes. And just know that this is I think if the high school teachers were saying, you know, like the students that have their own devices, that this works well instead of owning a graphing calculator. But as you are looking at these, and I don't know if they work on phones or that kind of thing, because I haven't used it, I haven't tried it on my smartphone as you're looking at them. So the first question says, what's the slope of each branch? Devin, what's our slope of each branch? If I wanted to go from rise to run, keep going up here, what would I have the slope of this side is? Okay, it's going to be a positive one, right? Positive. On the other branch, it is, we're going down this side, Hannah, what's my slope? Down 1 over 1, it's what? Okay, but it would be a positive 1 or negative 1? On this side? Negative 1, right? So, thinking of that slope guy when we had that picture, right? Our two branches, one was positive, one was negative. Where was our vertex? Our vertex was at negative 1, negative 2. This next one, x-intercepts. X-intercepts means where does it cross the x-axis? We had 2 of those. One of them is located over at negative 3, 0. The other x-intercept is located at 1, 0. Okay, so these 2 points that we are talking about. Domain and range, it's back. Some of you were thinking when they were going to hit that again after that last test. It's back. It's going to keep coming back all year. Domain means what are the x values that you can have that will work. So when you're thinking about this, are there any x value that we could not put in along this number line? Can I just say I can only put positive numbers in? No, because I have negative. Can't put, so our domain is going to be all reals. Okay? When we talk about our range of our function, remember that is our y values. So if we are thinking about our y values, do we have all the y values here? Do I have all the y values along that y? Do I have y values down here? No, I don't have any y values down here. So when it says what is your range is going to be where y is greater or equal to negative 2 for all reals. Okay? And then it says, well, do you notice a connection between the vertex and the numbers in the equation? And to explain. And this is really key to where that equation that was in your homework on 35. Y equals absolute value of x minus h plus k. If we are looking at this form of an absolute value equation, it is going to tell us the vertex is going to be located at hk. It should still have a slope of 1 and negative 1. The only thing that moves is your vertex. So we're going to try a couple. Y is equal to, I want you to put the absolute value of x minus 2 plus 7. Write that equation. Tell me the vertex right below it. Put y equals absolute value of x plus 4 minus 8. And again, tell me the vertex. So thinking about, as we look at this, thinking about our x minus h, and this is our h. And then if this is a plus k, this is exactly k. So the first one, check with your shoulder partner and the people sitting by you first right now. Do that. Check with your vertexes and see if you agree. Do that right now. Hey, do you think this is the right, does this make sense? Yes, no? Okay, so check with the people by you. Check with someone. I need you to check. Okay? All right, one person, Samantha from your group, want to tell me, what do you guys have?
2, 7.
2, 7. Over on this side of the room, someone want to tell me what you guys had for your vertex? One of you, someone.
4, -8.
I agree with -8. Why not 4? Why not 4? This equation has to be a minus. So if we think of this as a minus, it has to be x minus a -4, right? So my vertex is -4, okay? -4, -8, I would agree with, okay? So be really careful for that. It's the same like when we did point slope, where you have to be careful for the y minus and x minus, okay? So it says, does it open up or down? Which graphs, just looking at these 5 equations, A, B, C, D, E, which ones are going to open up or down? Okay? And then we're going to use our device and we're going to put these in and we're going to graph all of them. Okay? So, which one should open up? Should A open up? If we are looking at it, what do you think? This is A. Is A going to open up? Mm-hmm. How about B? B should be down. How about C? Up or down? Up. D should be down, right? The negative on front. E should be up. It then asks you, how does the coefficient that is in front affect it? What I want you to do is put these 5 in your calculator. So to clear out an equation, you just click on that little X behind it. So click on today's daily planner on Desmos. Go to Thursday under math or algebra. Did you go? So when I look at it, this, oh, did I put it under Wednesday? I put it under Wednesday, I'm sorry.
I don't know. I'm not seeing it anywhere. Unless I missed it.
Just type in Desmos at the top and you'll get it. So if you just type in Desmos, it'll say Desmos calculator and you click yes. Okay? So as we are looking at that, you want to put in your equation. So we're going to put the parent function, the y equals absolute value of x. And then you'll go down to number 2 and you'll type in number 2, 3, 4, B, C, D, and E. Type all of those in, please. Do that right now. Type all of those equations in. So type in A, then type in B, C, D. So we're going to go with the y, it's always equal. When I'm typing B, I have that negative out in front. You're going to use the minus for that negative in front. Then you're going to put the absolute value. Notice if you just put x, what did it do already to it, right? It moved it down, it reflected it over, but our x was x minus 3 inside there, so keep typing it exactly as it's written, okay? So that's the second one, right? And we're going to go to the third one, type it in, right from your notes, the y equals, as we're looking at C, that one just started with an absolute value of x minus 3, and then we were outside our absolute value with a minus 1. Okay, so those two have the exact same vertex, right? They're just going in different directions. One was up, one was down, so that kind of confirms what we said before. This one started with a -2, so we're starting with that -2. So you're just typing in each one. So this is a really nice tool as you are looking at your at doing graphing and checking on things. And if you just type in Desmos, you'll get Desmos calculator, and it is super nice to be able to use. So we get orange one, and then the only thing, and notice that one, I didn't even put a y equals, it just put the equation. So even if you don't put y equals, it understands that you're graphing an equation, and you can just type the equation, okay? So as you're doing that on this, you can do it either way. And then we had 2 absolute value. X plus 3, and then outside we have that same -1. So it gets kind of crazy as you are looking at that. And if you click on the graph, it'll take away all that typing stuff once you do that. And you can zoom in, right, so you can see more of them, or you can zoom in closer. We don't want to get too much closer, okay? And we now want to go back and think about our questions that we want to answer here. So, if we are looking at our graphs, that wasn't supposed to happen, but that's all right. If it helps you to plot kind of those graphs on yours, to plot those points here. And the question said, as we are looking at this, does the sign of the coefficient in front, that's this, the sign of the coefficient in front, right? That's this. How does that, in front of the absolute value bars, how does that affect the direction of opening up or down? So if it's positive, what's going to happen? Positive, it's going to always open up, right? And if that is negative, okay, then our graph will open down. The next question asks us to look at the slopes. So, what are the slopes, the left and right branches of each graph? So again, if you want to look at those branches, which three have the exact same slope? A and what else? A has the slope of 1, so a slope of 1 and -1, right? So what are the slopes of the branches, the left and right branch of each graph? 1 and -1 are which graphs? A, what other one? B, there's one more. Which one has a slope of 1? Has a number out in front of 1. A, B, and what else? C, D, E, which one? C, do you agree that out in front of this there's a 1? Okay. If we are looking at slopes of 2 and -2, which graphs should be steeper? 2 and -2. Should be D and E. How does the slope of the left relate to the branch of the right? So how does the left, if we are looking at, how does the left relate to the right? How does the left relate to the right? How are those slopes? What could we say if we are talking about those slopes? Anyone have an idea? The left relate to the right. The 1 slope, then we have -1. We have 2 on one side, we have -2. They are what kind of numbers, Joy? Opposites. These are opposites. When we think of our branches and their slopes, they are going to be opposites. It says, how does the coefficient in front affect the slope? If the coefficient is greater than 1. And remember, when we talk about that coefficient, we're talking about that right in front of the absolute value. This is the coefficient that we're talking about. If it is greater than 1, and then you have this absolute value sign, okay? How does this affect our graph? If it's greater than 1, it's going to make it steeper. And I think yesterday the word they use is more compact. Okay? It's going to make, instead of it being 1, it's going to go up 2 and over 1, or up 5. It makes it much more compact. Okay? If that coefficient is between 0 and 1. So if it's between 0 and 1, meaning we have a decimal, right? We have a fraction. If it is between 0 and 1, then it is going to flatten our graph. Flatten the V. So it makes it much wider. It just flattens it out. Okay? Now, I have had some students saying, you know, Mrs. Thompson, I look back at our homework and I'm not sure about some of this stuff. Like, I didn't really get when we did linear inequalities. There's a video attached. Last week, some of you were coming in and saying, you know, I didn't get point slope really well. Is there any way I could review? I got a video with it. I got worksheet here. I did put those quizzes back up, but this is the video of standard form. So if you didn't get it, go back and watch it over again, right? Make sure you're understanding it. What they are asking you right now to do in this next part of your notes, it says, without graphing, look at this equation and answer these questions. So go through and do those right now, just looking at that graph. I want you to answer those 4 questions. And if you get stuck on domain and range, just do the first 3 and then put it in your, then put the equation in the decimals. But first answer those, okay? First thing I want you to be able to tell me, where is your vertex? Write it down. Open up or open down? What are the slopes as you look at this one, okay? Before you go to your Desmos calculator and put that equation in, make those predictions and see how right you are, okay? So kind of look at yours first. The nice thing about this is if you make a mistake typing it in, you can kind of just go back, and whereas on the graphing calculator, you always have to kind of go back and do the whole thing. So if I was looking at your graph, how close were you to your predictions? If we were looking at that. So if I'm looking at my predictions, how close were most of you guys? On or not? This is what came up, right, when we did it on our device, okay? So our vertex should have been at, if we were looking at that, should have been at +1, right? And +4, +1, +4, which if you look at that one, you can see 0, 0 up there. We have +1, +4. Did it open the direction you thought? Okay, so we should have predicted because of the negative out in front that it should have gone down. Someone said, how do you figure out your slope? Down 2 over 1, down 2 over 1. That one has a slope. So we have slopes of 2 and -2, right? This side is a +2 going up. This side has a slope of -2. How did we get that? That was our number in front. Domain. What kind of values can I put in for x? Domain should be, everyone, all reals. X's are almost always all the values. Whereas when we talk about our range, is this vertex a minimum or a maximum point? What would you say? It looks like a maximum. It's the top of our graph, right? Okay, a minimum would be a V that opens up. So this one has a maximum, which means my range has to be less than that top Y value. My range has to be where Y is less or equal to 4 for all reals. And hopefully as you put that in your device, you were able to see that, okay? I'm going to hand out the worksheet to you that you are working on.